Hi everyone, today we'll discuss some important questions of the last exercise of chapter Determinant from Ncert, and I have selected some important questions, and I do hope these questions will definitely help you to solve similar type of different questions. So one question is this, without expansion prove that this determinant is equal to this, ABC, A square, B square, C square, BC, CA, AB is equal to 1, 1, 1, A square, B square, C square, A cube, B cube, C cube. So we'll consider this one as the left hand determinant first, and we're going to prove this. Okay, what will be our step 1? Okay, this is left hand side. So what I'm going to do is, we are going to multiply the row 1 by A, row 2 by B, and row 3 by C. Why will be multiplying? Because you have seen that here A is missing, here B is missing, here C is missing. So in case if you multiply the first row by A, second row by B, and third row by C, you are going to get the same element in the third column. Okay, and there is a property that if you multiply a row or column by any number, same time the determinant to be divided by the same number. So in case if you multiply the first, second, third row by A, B, C respectively, the same time you have to divide the determinant by A, B, C. So your step 1 will be, you should divide this determinant by A, B, C. Why be dividing? Because you are multiplying the first row by A. If you multiply the first row by A, this will be A squared, this will be A cube, this will be ABC, and this will be B squared, this will be B cube, and this will be A, B, C, and this is A squared, so this is B squared, and this the third row you are multiplying by C, so this will be C squared, C cube, A, B, C. Okay, now what is the step 2? For the step 2, we have seen that this third column, ABC is common, so we'll take ABC common, ABC out from the third row. Already, third column, already ABC is there in the denominator, so this will be ABC. Now what is left out? What is left out is there is no change in the first and the third, second column, so it will be A squared, B squared, C squared, A cube, B cube, and C cube. And since you have taken this ABC common from the third column, so 1, 1, 1 will be left out. Now you can cancel this. Okay. Now you have seen that this is quite similar to the answer, but the only thing that their positionings are different. Okay. So what I'm going to do is, we'll first interchange the first column with the third column. So if we interchange this, and in case if you interchange a pair of column or pair of rows in a determinant, the determinant gets multiplied by -1. So what I'm going to do is, if we shift this third row to the first positions and first row to the third positions, so our resulted determinant will be 1, 1, 1, and it should be A cube, B cube, C cube, and the third column will be A square, B square, C square. But in answer, the third column should be A cube, B cube, C cube. So after the interchanges of the first column, we'll need to make another change. What will be the next change? We again will have to change the third column with the second column. That means we need to interchange two pair of columns here. So what I'm going to do this, for one change, one minus sign, we'll make two changes, so -1 squared. So what will be the changes? See this steps property. We'll first bring 1, 1, 1 to the first column positions. So we'll shift this first column to the third column positions. But again the third column and the second column will interchange. Therefore this A cube, B cube, C cube will be in the third column, and A square, B square, C square will be in the second column positions. Okay? Then this is A cube, B cube, and C cube. I hope this is the answer. With the help of only these steps, okay, you got the answer. And throughout this one, we are not using any expansion, because the question is that without expansion you need to prove. So we are using simple properties, and we got the answers. So this is the question about one of our today's class, and next we are going to take another are important questions, okay, from the same exercise. What is that questions? That the next question is this, that if, what is the questions? That if A, B, C are real numbers and delta, okay, the symbol of determinant delta, B plus C, C plus A plus B, okay, C plus A plus B, B plus C, okay, and this is A plus B, B plus C, and C plus A. If this is equal to 0, right? If A, B, C are real numbers and this delta is equal to 0, then what you need to prove that? Then prove that either A plus B plus C equal to 0 or A equal to B equal to C. That you need to prove. Okay? Either A plus B plus C equal to 0 or A equal to B equal to C. This is also a very important as well as interesting questions in the exercise. Okay, we'll just start with this. We'll start with this given condition. What is given? This determinant is equal to 0. So we'll start our steps from the steps. Okay, and it is given. So we'll start the solutions given this determinant is equal to 0. Okay, now we are going to we have seen like it is BC, CA, AB. Okay, now in case this R1, if we add R1 plus R2 plus R3, what will be this element? This element will be, there will be 2B and there will be 2A, 2C. That means here we are going to get 2 twice A plus twice B plus twice C. Similarly, we are going to get the same element in this position as well as in this position. So we are going to operate, that is R1 implies R1 plus R2 plus R3. So here you can use the column operation also. So we'll just go ahead. If we add this, we are going to get 2A plus B plus C, and similarly here also we are going to get the same element. Okay, right? I'll just write this because if you add this R1 plus R2 plus R3, you are going to get twice A, twice B, twice C. 2A plus B plus C, right? But we are not making any changes in the row 2 and row 3. So write as it is. C plus A plus B, B plus C, and what is the third row? A plus B, B plus C, and C plus A is equal to 0. Okay. Now what is the next step? What is the next step? Okay. Now in the next steps, you have seen the first row what is common. In the first row, 2A plus 2B plus 2C, that is twice A plus B plus C is common. So we are going to take that common. So twice A plus B plus C. We are going to take this common from the first row. So if you take common from the first row, what will be left out? The left out will be, this is 1, 1, 1. Then there is no change, C plus A. And this is A plus B. Okay, what is our next column? A plus B and B plus C. And this is B plus C, C plus A. B plus C, C plus A. Okay, this is equal to 0. This is equal to 0. So we have taken this element common. Then C plus A plus B, B plus C, and A plus B, B plus C, C plus A. This is left out. So I'm going to write the next steps here. Okay, what is the next steps? As I told you before, like when you get one entries in a row or in a column are all one, then we are going to follow a simple property. What is that? We are going to make any two ones 0 from the first row. So what is the next property we are going to use? Which is change C2 minus C1. And we are going to, that means we are going to make this 1 0. We should only focus about this number. There will be changes obviously for the column to column 3, but our focus will be to make 2 1 0. Okay, so we'll make the changes. Like C2, we'll subtract the column 2 from column 1. Similarly, we'll subtract column 3 from column 1. C3, that is C3 minus C1. So what are the changes? Okay, so here 2A plus B plus C implies, okay, and there is no change in the column 1 positions, that is 1, C plus A and A plus B, okay, and you are subtracting column 2 from column 1, so it will be 0, and if you subtract this one from this, A cancel out, you will get what? B minus C, okay, and if you subtract this one, B cancel out, C minus A, right? Okay, similarly, you are subtracting this one, 1 minus 1 is 0, this will be 0, and if you subtract B plus C from C plus A, this is C cancel out, B minus A, you are going to get B minus A, and last element, C plus you are subtracting from this one, A will cancel out, C minus B equal to 0. So obviously you are going to follow simple steps here. What is that? See, since you are making two entries 0, so next step is you can expand the determinant. So you will expand along the first row. If we expand along the first row, you need to multiply this element, then minus, you need to multiply this element. So the next step will be B minus C and multiplied by C minus B minus C minus A into B minus A, that's all, okay, equal to 0. You need to only multiply along 1 because other two entries are 0. So finally you got this. So we need to simplify, okay. How to simplify the next step, okay, how to simplify? This implies, okay, we'll just write these simplifications here, we'll write the simplifications up. Okay, what will be the simplifications? This implies twice A plus B plus C. We'll just multiply. So this is BC and that is minus B squared. Then we'll multiply by C, that is minus C, that is minus C squared. Then minus C and this is minus B, this is plus CB. Okay, then what is the next step? Minus C into B, that is minus CB, then minus C into, this is C into minus A, that is minus CA multiplied by minus, so plus CA, right? Then we'll multiply by minus AB, minus A into minus B, minus A into B, that is minus AB multiplied by minus sign, so plus AB, right? Then only last step is there, it is minus A, it's plus A squared multiplied by minus, so minus A squared equal to 0. So let's see, is any terms possible to cancel? Okay, so here you have seen the CB minus CB, will cancel out this term. So what is left out? This is twice A plus B plus C. Okay, then this is, I'll just arrange the terms. This is minus A squared, minus B squared, minus C squared. This is minus A squared, minus B squared, minus C squared. Then plus AB. This is plus AB plus BC plus CA equal to 0. So finally we got these expressions. What is the next steps to be followed? Okay, next steps to be followed is, what I'm going to do is, we'll just multiply these expressions with minus sign, and we'll multiply this expression with minus sign as well as we'll multiply by 2. So what is the next steps? A plus D plus C. And if we multiply by minus sign, because both sides obviously you can multiply by minus sign because right hand side is 0. So if you multiply at the same time with a minus sign and with 2, so these expressions will be twice A squared plus 2B squared plus 2C squared. And as because you are multiplying this whole expressions by minus, so this 1, 2, 3, all the terms will become negative. So it's minus twice AB minus 2BC minus 2CA equal to 0. So I can just tell you the logic behind this. Okay, your question was that you have to show either A plus B. Remember this, you have to show that either A plus B plus C is equal to 0, or already this term is there. So one answer is there with you that you can show A plus B plus C is equal to 0. But the next step is very important. Then how to show A equal to B equal to C. So to show A equal to B equal to C, so you need to write this expression. This expression is very important for you. Okay, this expression you should be able to write as a sum of squares. So you want to write this expression as a sum of square. These terms always should be twice minus twice AB minus twice BC minus twice CA. Apart from this, these other terms also will be multiplied by 2. That's what we are using this to multiply this. And since the sign of this first, second term to be all plus, therefore we have changed the sign. And since this is an equation, both the sides obviously you can multiply by either plus or minus. Now what is our next step? The next step is this: a plus b plus c. Okay, a plus b plus c. And these expressions, this one is a sum of 3 squared. It's a standard expressions. Okay, sum of 3 squared. I can show you how this can be. This is a standard expression, so that's what I have written directly. In case if you want to check the steps, then if you expand this, you will get a square plus b squared minus twice ab minus twice b. Then from this expression you will be getting a square plus b squared, and 1b squared you will get from this term, 1a squared you will get from this term. So therefore you are going to get twice a squared from there, b squared, one term is there, one term is there. You are going to get 2b squared, 1c squared will be there, 1c squared will be there. You are going to get 2c squared. From each term you are going to get 1 minus twice ab, 1 minus twice bc, 1 minus 2ca. So this is a standard expression that can be expressed as a sum of 3 squares. Okay. Now, see, this is the product of two terms. The product of two terms is equal to 0. So you can come to the conclusions either or. Okay. So we can write finally either a plus b plus c equal to 0, or a minus b. Okay, a minus b whole square plus b minus c whole square plus c minus a whole square equal to 0. You can write it because product of two term is 0. Either this term is 0 or this term is equal to 0. So what is the next step? Next step is, that is a plus b plus c equal to 0, or see, this is 3 square number. Sum of 3 square equal to 0. So what is the only possibility? Only possibility that individual all the terms should be 0, or a minus b equal to 0, b minus c equal to 0, c minus a equal to 0. Therefore, either a plus b plus c equal to 0, or from this we are going to get a equal to b equal to c. Because from this expression we are going to get a is equal to b, from here b is equal to c, from here is equal to c is equal to a. So if you combine the three equations, you are going to get a equal to b equal to c. So this is the final answer of that question number 2. So let us go to another important question. The same exercise. Okay. Now what is the next questions? The next question is coming up is this. Okay, prove that this next questions. Prove that, okay, a squared plus ab, bc, b squared plus bc, AC plus C squared, AC, C squared is equal to 4 A squared, B squared, C squared. So this is also one important question. It's given, prove that. So if this question is asked like that, you should know like you are going to use the properties. You can of course at the end you can expand it. It's not given like you without expansion. It's given prove that. Okay, we understand that prove that using properties. So we are going to start the sum. Listen everyone, dear students, if you are watching this video, and while going through the video, a simple trick I am telling you, and it will definitely help you, that when you go through the video, you please, the moment you get a sum, you start doing by yourself, okay? And you can just make the video pause and you solve it, and then you can compare the answers. Definitely that way it will help you to learn by yourself. Okay, let us solve this sum with this left hand side. Okay, now what is your observations for the first column? Okay, in the first column we have seen that A is common. Similarly, in the second column B is common, and the third column C is common. So we are going to take A, B, C common from the first, second, and the third column respectively. So we are going to take A, B, C common. Okay. If you take A common, it will be A. This will be A plus B, and this will be B. Fine. What is left in the second column? You are taking B common, so it will be C. This will be B. This will be B plus C. Right? Okay. Now from there you have taken C common, so it will be A plus C and A and C. Done. This is an obvious steps because you have seen this numbers are common, so we'll take the common element. The moment you take common element, the things becomes easier. Okay. Now you have to think like what is the next steps to be followed. We'll try and keep on simplifying these questions. Okay. And we have not seen any common elements now, and in case if we apply for the addition of rows and columns, we are not going to get much benefit, okay? Because if we add this R1 plus R2 plus R3, here we are going to get twice A plus 2B, but here you don't get twice A plus twice B. You get here twice B plus twice A. Both the elements are different, so we are not going to follow this steps. So A, B, C. But you can do one thing. Here we are going to apply this one. So we'll just subtract R2 from R1. R2 minus R1. Similarly, we are going to simplify the third row as well. Third row that is R3 minus R1. R3 minus R1. I'll tell you why these steps are being used. Okay. So there is no change in the row 1. This will be A, C, A plus C. Okay, there is no change here. A, C, A plus C. So if you subtract this element, so obviously this one, then A will get cancelled out. You are going to get only B because A plus B minus A. Then here you will get B minus C. Okay, and if you subtract this one, what will be there? A will be cancelled out. You are going to get minus C, right? Then, if you subtract B minus C, so third row from the first row, B minus C, this is B minus C, and you are subtracting B plus C minus C, so C cancel out, it's B. Then if you subtract C with A plus C, that CC will cancel out, it's minus C. Okay, this is minus A, right? Yes. Using this one, you are subtracting R2 from R1. A plus B minus A, so it's B minus C, it's B minus C, A minus C, so A cancel out, it's minus C. Similarly, B minus A, then B plus C minus C, CC cancel out B, then C with minus A minus C, CC cancel out, it's minus A. Fine. Now, if you apply this steps, if you use this property, now you are going to get one benefit. What is that? So just what I'm going to do is, now we'll be applying R1 plus R2 plus R3. Okay, so if you apply what are we going to get here? If you add A plus B minus A cancel out, you are going to get twice B there. And if you add this, CC will cancel out, you are going to get twice B. And if you apply A plus C minus C and minus A here, minus A and plus C and minus C will get cancelled out. You are going to get 0 here, and you are going to get here 2B, here also you are going to get 2B. That means you can take 2B out from the row 1 only because of this rules being applied. Okay, so the next steps is R1 plus R2 plus R3. Remember this. Okay, so if you add, so A plus B minus A cancel out, you will get twice B. And if you add C plus B minus C plus B, CC cancel out, you are going to get twice B. Right? And if you add this, A plus C, then minus C minus A minus A cancel out, plus C minus C get cancelled out. We are going to get 0. And remember, we are not making any changes for the row 2 and row 3. So please write row 2, row 3 as it is. So it's B minus C and minus C. Done? Okay, that is B minus A, then B minus A. Okay, now what is the next step to be followed? What is common in the first row? you have seen the first row 2b is common, so we'll take 2b. Already ABC is there, we'll take 2b also out. So what will be the first row? It's 1, 1, 0. And this is B, this is B minus C, B minus C, this is minus C, this is B minus A, and this is B, this is minus A, right? Okay, A is equal to. What is the next step to be followed? So you can multiply this, so this will be twice A, B squared, C. What is the common steps to be followed? It may be coming to your mind, okay? Yes, I know you can at least quickly tell me the answer. What is that? This element. Where 2 ones are there, you can make one entry 0. How can you do that? So it is subtracting C2 from C1. So we'll be applying this C2. You can just write here C2 implies C2 minus C1. We'll do that. Okay. So what will be the steps? Here 1 B minus C. Right? So C2 will subtract from C1, so it will be 0. And B minus C minus B. What will be left out? It's obviously minus C. If you subtract B minus C minus B, so B and minus B will cancel, minus C will be left out. If you subtract B minus B, and this is plus A, so only A will be left out. Now if you subtract, okay, we are not changing the column 3, this will be 0, this will be minus C, okay, and this will be minus A, right? This will be left out. So we are applying C2 minus C1, means 1 minus 1, 0, B minus C minus B. So this minus C left out, B minus B, and this will be plus A. It's plus A is left out, and there is no changes in the column 3. 0, minus C, and minus C, and minus A. Now let us go for the next step. Okay, we have left with only one step. Okay, what is that step? Here it's multiplied, the determinant is multiplied by 2 is A B squared C. Now since you have seen the first row 1 0 0, we can obviously expand. We can expand along the first row. So 2ab squared, and if you expand, this will be minus C and minus A. Minus A means this is CA, right? This is CA, because minus plus. Then minus, there will be another extra minus, then minus plus AC. So plus AC, right? So this will be 2ab squared C multiplied by 2ac. So it will be 4a squared b squared c squared is equal to right hand side. So this is also another very important questions. Okay. So next we'll take another important questions from the exercise. So what is the next questions coming out? Okay. And in case, as I suggested you, like if you are solving along with me, obviously you will enjoy. Okay. What is the next questions? The next question is this. Next question is evaluate. Okay. This is evaluate. What is the value? X, y, x plus y, then y, x plus y, x, then x plus y, x, y. Right? So evaluate. If the question is asking like evaluate, so you should know that they are asking to evaluate without expansions. Okay, without expansion, and then the last step you can expand, and naturally you need to evaluate this with the help of properties without expansion. Okay, expansion is possible. The expansion can be done after using all the properties. Okay, so let us start the sum. Okay, what is the common step to be followed here? The common step. Okay, let us see the observe the terms. Here x, y, x plus y. If you just use the property R1 plus R2 plus R3, let us see, do you get any help? So if you add x plus y, then x plus y. So you will get 2x plus y there. Twice x plus twice y. Similarly, you are going to get the same element there. You are going to get the same element there. So that is an obvious choice. We are going to take use this property, that is R1, R1 plus, R2 plus, R3. At the same time, remember one thing, same time that property can also be applicable in the column also for some, of course, for some determinant. Okay, so just apply this, and in this same determinant, you can apply the property of the column also. Okay, R1. So what will be the first element? So this will be 2x plus y. This will be 2x plus y. This will be 2x plus y. Done? Okay. And what is the second row element? Y, x plus y, and x. Right? And this is x plus y. This is x. This is y. Because we are not making any changes. We are not making any changes for row 2 and row 3. Okay. Now what is common in the first row? The 2x plus y is common, so we are going to take this common. Okay, next step. What is the next step? Next step is we will take 2x plus y common. So if you take twice x plus 1 common, so it is 1, 1, 1. This is left out, and y, x plus y, then x, and x plus y, that is x, and this is y. Okay, yes, this is the steps. So I hope like next steps is an obvious steps. It will definitely will come to your mind. What's the next steps? What is the next steps? Yes, right. What in the first row we have got 3, 1. Okay, we are going to make any to 1, 0. So what rule we are going to apply? That is called C2, C2 minus C1, and C3, C3 minus C1. Just you can write this. C2, C2 minus C1, and C3, C3 minus C1. Okay. What is the next step? X plus y, 10. Since you have seen that we are not making any changes in column 1, so column 1 you will write as 1, y, x plus y. 1, y, x plus y. If you subtract 1 minus 1, it will be 0, and x plus y minus y. So y will cancel out, you will get only x. Then if you subtract x minus y, so minus y will be left out. Remember this. Okay. Then you subtract 1 minus 1, it's 0. Then x minus y. Then if you subtract y minus x minus y will get cancelled out. You will get only minus x. Yes. This is the step. So what is the next step to be followed? 2x plus y. So the obvious step is, since the first row has 1, 0, 0, we are going to expand this determinant along the first row. If we expand, what is the value? Okay, so we will have to multiply this. So it will be minus x squared, and there will be one extra minus sign, that is plus y. Because already minus y is there, so if you multiply this minus will be plus y, that is x minus y. Okay, right? That is 1 x into minus x. This is minus x squared. Then this is minus it's plus. Then this is plus y and x minus y. Okay, let us check the steps. Here 1 y x plus y, 1 minus 1 0, x plus y minus y. Okay, here x will be left out. Then x minus y, it's minus y. And what are the steps here? The third column should be 1x y. So the third column we are subtracting from 1 minus 1. This is 1 minus 1 is 0. Then x minus y, that is y minus x minus y. Okay, the third, I think this element that is it's minus x, it's correct. Okay, so if you expand along the first row, this will be x into minus x. So it has to be minus x squared. Then there will be another minus sign. This is plus y, x minus y. So what is the next steps? This is 2x plus y. Okay, we'll just simplify this. Minus x squared, that is plus xy, then minus y squared. Right? Okay. Now, if we take a minus common from here, so it will be minus 2x plus y. Then this will be x squared minus xy plus y squared. Right? This will be if you take a minus common, it will be plus, this will be minus, and this will be plus. So if you take a minus common, so it will be minus 2x plus y, x square minus xy plus y square. What is this formula? A plus b, a square minus ab plus b square. This is equal to x cube plus y cube. Okay, what is x cube plus y cube formula? X plus y, x square minus xy plus y square. So this is the value of the determinant. Okay, this is equally simple questions. Okay, we are using the property. We are expanding at the last steps. Okay. Next, we'll take another very important as well as interesting questions from the miscellaneous exercise. It has got many important and some questions are obviously simple and some questions are tricky. Okay, and I hope in case if you solve many questions apart from this, so you will definitely start liking the topic and it will definitely help you to score marks in the board as well as in your entrance. Okay, what is the next question? Okay, the next question is prove that. Next question is prove that alpha, beta, gamma, alpha squared, beta squared, gamma squared, beta plus gamma, okay, gamma plus alpha, alpha plus beta is equal to beta minus gamma, gamma minus alpha, alpha minus beta multiplied by alpha plus beta plus gamma. This is a question. Okay, prove that alpha, beta, gamma, alpha square, beta square, gamma square, beta plus gamma, gamma plus alpha, alpha plus beta is equal to this. So this is also a very common type of questions. So how to proceed these questions? Now before you go, please observe the terms. So observe this term carefully. What is that? Beta plus gamma, gamma plus alpha, alpha plus beta. Had it been alpha plus beta plus gamma, everywhere you could have taken common, right? Then in case you can create this one is alpha plus beta plus gamma, alpha plus beta plus gamma. Everywhere you can take out, then you will get 3, 1 in the third column. The moment you get 3, 1, entries, all the entries in a column are ruled as 1. So next step is an obvious steps. Okay. So what we are going to do is, we are going to do the same thing. We are going to make this column alpha plus beta plus gamma. How can you do that? To make this column as alpha plus beta plus gamma, you utilize column 1. So we are going to apply this rule. So this is left hand side. So we are going to use this property, that is C3, we are going to change C3 plus C1. Remember this. We need only to add C1. We don't need to add C2. We are not going to use that. So C3, C3 plus C1. There is no changes in column 1 and column 3. Remember this. Column, there is no changes. So since there is no change, you write as it is. This is alpha, beta, gamma. This is alpha squared, beta squared, gamma squared. This is alpha plus beta plus gamma. Because you are adding this. This is alpha plus beta plus gamma, and this is also alpha plus beta plus gamma. Done? Yes. Okay? Yes. This is the next step. Now what is common in the third column? Alpha plus beta plus gamma. So this will obviously come out. And there is a hint in the answer also. In the answer you have seen that one term to be shown as alpha plus beta plus gamma. That will also help you how to proceed. Okay? In case you find it, then how to start, because different question has got different property, different rule to be used. Okay? So I can just tell you that some questions where prove that type of questions, you can get some hint from the answer as well. Okay? You got alpha plus beta plus gamma. Now what is the left out determinant? This is alpha, beta, gamma, then alpha squared, beta squared, gamma squared. It will be 1, 1, 1, right? Okay, so what is the next rule to be applied? Next rule is very simple. I don't find any reason again to explain you. We are going to make this 1 and this 1 0. It means we are going to change R2. R2 minus R1, R3 minus R1. So you can write that steps. That is, we are going to change R2. That is R2 minus R1, R3, R3, minus I1. There is no change in the first row, so alpha squared 1, beta minus alpha, then beta squared minus alpha squared, beta squared minus alpha squared, 1 minus 1 is 0. Done. Then gamma minus alpha, then gamma squared minus alpha squared, then 1 minus 1, 0. Right? Yes. You got this. Alpha squared 1, and there are some changes in row 2 and row 3. So what is the next steps? And here, before we expand the determinant, as you have seen, if you compare the solution of the previous questions, the moment we get that 1, 0, 0 entries in a row or column, start expansion. But it depends, like in these questions, before expansions, we need to see is there any term to be taken out. Is any term common in the row or column? So in cases there, you need to take out those terms, then only expansions to be done. So here what you have seen, in the second row, beta minus gamma is common, and the third row, gamma minus alpha is common. So we are going to take these two terms common. So what is the next step? Next step will be alpha plus beta plus gamma, alpha plus beta plus gamma. Then we are going to take beta minus gamma, and gamma minus alpha common. We are going to take this common. So if you take this common, what will be left out? So it will be alpha and beta minus gamma you have taken common, it will be 1, and gamma minus alpha you have taken common, this will be 1. And this will be alpha squared. And from here beta squared minus alpha, this is beta squared minus, this one is alpha squared. This is alpha beta gamma, this is alpha squared beta squared gamma squared. Okay, this is beta minus, okay, just 1 minute, this is beta minus alpha. Okay, this is correct, this is beta minus alpha. Okay, this is beta minus alpha, we have taken beta minus alpha common, right? This is beta minus alpha. So beta minus alpha, so beta square minus alpha square, beta square minus alpha square, beta minus alpha you have taken common, so beta plus alpha will be left out, beta plus alpha will be left out. Okay, this is 1, 0, and here gamma minus alpha you have taken common, so here gamma plus alpha will be left there, gamma plus alpha will be there, and what will be left out? Here is 0. Okay, just we can write the steps as this. Okay, this is the determinant, right? Okay. Now we will expand this. How do you expand this? What is the next step? Next step is alpha plus beta plus gamma, and this is beta minus alpha and gamma minus alpha. And if you want to expand this, okay, if you want to expand, we'll expand along the third column. If we expand along 1, we need to multiply 1 into gamma plus alpha. So it will be gamma plus alpha and minus beta minus alpha, right? Okay, so finally you got these expressions is equal to alpha plus beta plus gamma, and this is beta minus alpha, and this is gamma minus alpha, and here what will be cancelled out? Here alpha cancel out, this is gamma minus beta. Okay, gamma minus beta. So it's almost the answer. Only what you need to do is we have to arrange the terms in a proper order. What is the order given? Always this order will be given from alpha minus beta form. Okay, so here we'll drop this part, and we are going to change the answer in this way: alpha plus beta plus gamma. Okay, and this is given as alpha beta gamma. So we are going to change this. Beta minus alpha will be writing as alpha minus beta. Then we need beta minus gamma. Then we have gamma minus alpha. Gamma minus alpha is already there. So what we have done? Can you write this one? Because we are changing the order of beta minus alpha. We have changed the order of gamma minus beta. So if you make this order change, like beta minus alpha, if you write alpha minus beta, there will be a minus sign. If you change the order of gamma minus beta to beta minus gamma, there will be another minus sign. So minus minus become plus. But remember this, here, this gamma minus alpha, this gamma minus alpha, there is no change. So finally, what was the questions? They have to prove the determinant as alpha plus beta plus gamma, alpha minus beta, beta minus gamma, and gamma minus alpha. So this is the answer. Okay. Next, we'll move to another important question. Okay. What is that? There are a few more important questions. One question is this, that prove that, okay, these questions, prove that x, y, z, x squared, y squared, z squared, 1 plus p x cube, 1 plus p y cube, 1 plus p z cube equal to 1 plus p x y z, x minus y, y minus z, and z minus x. This is also another important questions in that exercise. Prove that this determinant is equal to this. Okay, so how to prove this? Okay, so we'll take this one as a left-hand determinant. We are going to prove this. Remember this, here you need the terms like x minus y, y minus z, z minus x, and you need a term of 1 plus p x, y, z. Okay? Now let's just focus, before we go, let us observe the terms. Okay? Here you have seen the third column. We focus on the third column. The third column is expressed as the sum of two numbers. So we had one property now. If a particular column or a row is expressed as a sum of two numbers, the whole determinant is expressible as a sum of two determinants. So express this one as a sum of two determinants. So that important property we are going to use it. So x, y, z, and there is no changes for the both the determinant. There will not be any changes for the column 1 and column 2. That is x, y, z. This is x squared, y squared, z squared. Then it will be 1, 1, 1. Then let us write the second determinant. For the second determinant as well, the first column and the second column will remain as it is. So it's x, y, z, x, y, z, x squared, y squared, z squared. This is p x cube, p y cube, p z cube. Right? Okay, and we have expressed this one as a sum of two determinants. Let's see what is the next step to be done. So you have seen like this is already a simplified determinant. The third column has got 1, 1, 1. So if you separately want to simplify this determinant, you can make 2, 1, 0. Okay, using R2, R2 minus R1, R3, R3 minus R1. But since along with this one determinant is there, we are going to first simplify this determinant. Okay, and after that we'll use a common property for both the determinants. Okay, otherwise, if you treat this one separately, unnecessarily you will have got more steps. Okay, so what I'm going to do is, okay, this is x, y, z, x, y, z. This is x squared, y squared, z squared, x squared, y squared, z squared, and this is 1, 1, 1. Okay, and what you have seen common in the first row, it's x, and second row y, and third row z. And apart from this, what is common in the third column? It's p common. So many things can be taken common from the second determinant. What you can take common? You can take this x, you can take common from, okay, then plus, you can take x common from the first row, y common from the second row, z common from the third row, p common from the third column. So it's x, y, z, p. Okay, after that, what is left out? It's 1, 1, okay, 1, 1, 1, then this is x, this is y, okay, and this is z, and you have taken p out, Apart from that, from x cube we have taken x common, so it will be x squared, this will be y squared, and this will be z squared. Done. So it's coming similar to this determinant, but the only thing that the similar columns occur in the different positions. Okay, so what property you can use next? What I'm going to do is, how to take this determinant and this determinant. We'll just make exactly same. So how to do that? What I'm going to do is, like, we'll shift the first column to this third column to the first column positions. And this x, y, z should be in the second column positions. First, we will interchange the first and the third column. Then we will make another interchange with the third column and the second column. That means we need to interchange two column changes for the first determinant. You know, like for one changes, that means if you change one pair of column interchange, then they will be multiplied by 1 minus sign. And if you make two changes, they will be multiplied by 2 minus sign. That is minus 1 to the power 2. Okay? So minus 1. So for that, 1, 1, 1 will be in these positions. And x, y, z will go to the third positions. But we will make one more change. That x, y, z will be to the second column position. This will be x, y, z. And finally, x square, y square, z square will be in the third column positions. Why you are doing that? I think you have the logic for this. Why we are doing this? Because this determinant entries are same as this, but their positionings are different. So you have to make this determinant, both this determinant as same determinant, so that you can take the determinant common. So we don't need to make any changes for this determinant. This is 1, 1, 1. This is x, y, z. This is x squared, y squared, z squared. Right? X squared, y squared, z squared. Now, what is the next steps? Next step is this. Next step is, okay, next step is, this will be obviously plus. So take this 1, 1, 1, x, y, z, x squared, y squared, z squared. We are going to take this determinant common. This determinant common. If you take this determinant common, what will be left out here? Here it will be left out 1, and here it will be left out p, x, y, z, right? So this is a term, like this term you have taken common. So here 1 will be left out because minus 1 square is plus. And if you take this one common, here is 1 multiplied by p, x, y, z. Finally you got these steps. Now, as I said before, you are going to simplify this determinant. Instead of two determinant, we have converted to one determinant. Now the steps will be easier. Okay? So we are going to change R2 with the help of the R1. R2, that is R2 minus R1. Then R3, 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 R3 minus R1. So what is the next steps? 1 x, x squared. If you separate 1 minus 1 is 0. That is y minus x. Then y square minus x square. Y square minus x square. Right? 1 minus 1 is 0. And this is z minus x. Then z square minus x square. Z square minus x square. Done. And multiplied by 1 plus p x y z. Done. So now we'll follow the next steps. What is the next steps? Next step is, from the second row what you can take common? Y minus x, as you have done the previous questions. And from the third row what you can take common? Z minus x. So already 1 plus p x y z is there. We'll just write this one, 1 plus p x y z. And what you can take common? You can take common as y minus x. You can take y minus x common. Apart from that you can take z minus x common. After taking all common, what will be left out? What is that left out determinant? Here 1, 0, 0. This is 1, 0, 0. Done. And here y from the second row we have taken y minus x common. So x 1, x 1, 1. Because from this one you have taken z minus x common. So here x is squared. And since y minus x you have taken out, so it will be y plus x. Y plus x. And from this element, z minus x you have taken common, this will be z plus x. Right. You are coming towards the end of the answer. Now, here, you can write the steps. Okay. is equal to 1 plus p x y z multiplied by y minus x z minus x. Now we're just expanding along the first column. If you expand along first column, so you have to only expand along 1. So if you expand along 1, what you will left out? 1 into z plus x is z plus x minus y minus x. So x cancel out. So finally, this is 1 plus p x y z and y minus x z minus x, and this is z minus y. Okay, let us compare the answers. Okay, and this answer also, that the expression is given in terms of x minus y, but it's coming as y minus x. So what are the changes to be made? Okay, we have to make this changes. Remember this. What is that? Y minus x need to change. This should be x minus y. X minus y, y minus z. We have to make this changes. And j minus x should be remain as it is. So we are going to change the order of y minus x and j minus y. Okay. And finally, this is 1 plus p x y z. So we'll change y minus x is x minus y, and j minus y is y minus z. And you know, like if we make the changes of the two expressions, there will not be any difference in the answer. Why? Because y minus x, if we make x minus y, 1 minus sign will be there. And for z minus y, if you make it y minus z, it will be multiplied by another minus sign. So minus minus will become plus. And we don't need to make any change on this term. That is j minus x. Z minus x. So finally, x minus y, y minus z, z minus x. And this is your answer. Okay, so these are the steps to be followed to solve this type of questions. And we have one important question based on the trigonometry. We're going to solve this. Okay, and these are the questions what we have done mostly from algebraic terms. We're going to start one question from trigo. Let's see these questions. What is the question? The question is, prove that, okay, prove that sin alpha, sin beta, sin alpha, sin beta, sin gamma, cos alpha, cos beta, cos gamma, and cos, okay, alpha plus delta, cos beta plus delta, and cos gamma plus delta equal to 0. These are questions. Simple, they have asked that prove that this is equal to 0. So how to solve this? And you should know that you are not supposed to expand this. We are going to use the properties. Okay? So how to solve this? So left hand side. This is left hand side. Okay? What the rule we are going to follow? Have you seen this is cos A plus B? So we are going to expand this formula, cos A plus B formula, for all the three terms. So the first column will be sin alpha, sin beta, sin gamma. Sin gamma. This is cos alpha, cos beta, cos gamma. Then we'll expand this. It will be cos alpha, cos delta minus sin alpha, sin delta, cos beta, cos delta minus sin beta, sin delta. Similarly, for cos gamma plus delta, cos A, cos B minus sin A, sin B. Cos gamma, cos delta minus sin gamma, sin delta. Okay? Now, what is the next step? Next step, we are going to use a very simple property. What is that? If you observe the third column is a binomial. Third column is a binomial. Each term is a binomial. So we are going to express this determinant as a sum of two determinants. What is the next step? Next step I am going to write here. See this. Okay? First row, first column, second term, there is no change. Sin alpha, sin beta, then sin gamma, then cos alpha, cos beta, cos gamma. Then this term, this is the first term, this is the second term. First term is cos alpha, cos delta, cos beta, cos delta, cos gamma, cos delta. This is the first determinant. Then since this is expressed as the sum of two numbers or difference of two numbers, the whole determinant can be expressible as the sum of two determinants. One is this column, and third column will consist in this. And for the second determinant, first column, second column, and the third column will consist in these elements. Okay. Now, what is the second determinant? Second determinant is sin alpha, sin beta, and sin gamma, and cos alpha, cos beta, cos alpha, cos beta, cos gamma, and here it will be minus sin alpha, sin delta, minus sin beta, sin delta, minus sin gamma, minus sin gamma, sin delta. Okay? Yes, we have expressed this one as a sum of two determinants. So next step is quite interesting. See that. Okay? Now from the first, this one, let us observe this. What is common for the first determinant? What is common in the third column? Cos delta is common. So we'll take cos delta out. What will be left out? It's sin alpha, sin beta, sin gamma, then cos alpha, cos beta, cos gamma. This is cos alpha, cos beta, cos gamma. Okay, plus here for the second determinant, what is common in the third column? It is minus sin delta. So we'll take minus sin delta common. Minus sin delta. If you take minus sin delta common, what will be left out? Sin alpha, sin beta, sin gamma. Cos alpha, cos beta, cos gamma. Okay, minus sin delta is not taken common, so it's sin alpha, sin beta, sin gamma. Now, you have seen like here cos alpha, this column and then this cos alpha, cos beta, cos gamma, cos alpha, cos beta, cos gamma. Both are identical columns. Here, first column is sin alpha, sin beta, sin gamma, and the third column is sin alpha, sin beta, sin gamma. Both are identical columns. So since identical column, so obviously it will be 0. So this will be 0, and this is also 0. Finally, this is 0. This is right hand side. Or this is also an simple questions. Okay, and we'll be solving the last questions of today's class. Okay, and since this exercise has got many more important questions, therefore we had to include the maximum number of sums. Okay, and I suggested you, and if you are solving along with me with the help of yourself or taking some inputs from my class, definitely it will help you. Okay, the last questions we are going to solve. Okay, what is this questions? If A, B, C are in AP, that is arithmetic progressions, then evaluate x plus 2, x plus 3, x plus 4, x plus 3, x plus 4, x plus 5, x plus twice A, x plus 2b, x plus 2c. These are the questions. If ABC are in AP, then evaluate x plus 2, x plus 3, x plus 4, x plus 3, x plus 4, x plus 5, x plus twice A, x plus 2b, x plus 2c. Okay, and we'll start with this steps. Since it's given A plus B, A, B, C are in AP. Okay, let's solve this, evaluate solutions. Since A, B, C are in AP, therefore 2B is equal to A plus C. Okay, we know that this is a simple rule for arithmetic progressions. 2B is equal to A plus C. We are going to use the property in the determinant. While using the property, in between we are going to use this. Let's see whether we get the answer or not. Okay, have you seen the term A plus C? A plus C. So we are going to apply the rule in a way so that we get the term A plus C. Where do we get A plus C there? Can you have an idea on that? A plus C? Yes. If you observe properly the first row and the third row, what I'm going to do is we are going to add row 1 with row 3. Done. Okay. So row 1 we are going to change row 1 plus row 3. This is a logical steps. So since A plus C, we need a term A plus C. Otherwise, if you don't get a term A plus C, how can you replace A plus C as 2B? So what is the next step? Next step, you are adding this and this. So it will be twice x plus 6. You are adding this one and this will be twice x plus 8. So you are adding this one and this, so twice x plus twice a plus 2c. So you can just write 2a plus c. Done. Right? There is no changes in R2 and R3. So it will be x plus 3 and x plus 4 and x plus 2b. And the last step is x plus 4 and x plus 5 and x plus 2c. Done. Let's see what is the next step. Next step is this. Okay, what will be the next steps? You can solve the next step as this. Okay, right. What you can take common from this? Okay, first, what are you going to do this? We are going to replace this A plus C. So twice x plus 6, twice x plus 8. We are going to replace A plus C. What is A plus B? A plus C. A plus C is equal to twice B. Don't forget this. Twice x plus. If it is twice B, 2B into 2. It's 4B. Right? It is 4B. And this is x plus 3. This is x plus 4. And this is x plus 2B. Okay? And third row will remain as this. X plus 4, x plus 5, x plus 2C. Right? And observe the first row carefully. What is common in the first row? Here 2 is common. Okay, 2, we'll take 2 common from the first row. If you take 2 common, what is left out? Here is left out x plus 3. And here it will be left out x plus 4. And here it will be left out x plus 2b. X plus 2b. And I hope you got the answer now. Yes, right. And first row and second row, it's coming in exactly same. So we'll just write the third row, x plus 5, x plus 2c. So your obvious answer, what is your obvious answer? 2 rows, identical rows, it's obviously is 0. This is the answer of this determinant. And thank you so much for attending my class. And I hope with the help of this many questions that you have seen or you have done by yourself by going through this video, it will definitely help you in scoring more marks, or and you can obviously solve many more questions. Thank you so much.